The huge Amazon rainforests are the lungs of the world. The trees take up carbon dioxide, release oxygen, and expel enough water vapor to change the climate and produce rain. But research into how forests do this is taking place far from the Amazon, over Australia's deserts and its Great Barrier Reef. Jörg Hacker runs Airbourne Research Australia, dividing his time between sampling the atmosphere from extraordinary aeroplanes and analysing the data with the complex modern tools of remote sensing.
Our work focuses completely around using aircraft and aircraft technology to study the environment in its widest sense, from the Earth to the atmosphere to the ocean, clouds, everything that has anything to do with the environment. The remote sensing technology we use are, for instance, lasers, where we measure the topography of the ground. We use infrared sensors, which look at the temperature of the surface, be it the ground or be it the ocean. We use that look at individual spectral bands, and high-definition cameras, for instance, cosmic radiation that is reflected from the ground. We use very special aeroplanes for our work. They are specifically built for the research we are doing. Most of the time we fit the instruments into pods that are under the wings, but we have also instruments that hang under the fuselage or on the wingtips or in other places at the aircraft. Our high-altitude aircraft, the Grobig Red, was developed in Germany basically at Cold War time to look across the Iron Curtain. There's only one of these aircraft available in the world, and it's the only one in the world that can fly very slow.
Put instruments in on these things?
Yeah, every setup we do is different, so we have to... Then we go into the field and we fly certain patterns, long traverses at different altitudes, or we fly more specific patterns depending on what we see in the atmosphere. We are the only group in Australia using this technology and this type of aircraft for our research. In fact, we are the only group using aircraft for research in Australia. When you use laser to study the environment, you shoot one laser pulse after the other down to the ground. That laser pulse not only bounces back from the ground, but it also bounces back from anything that is on the ground. For instance, if you look at a river landscape, your laser will bounce back from the water surface of the river. Then it will bounce back from the trees that might be on the shore of the river. You can tell how high the trees are. You can tell the density of the trees. It might bounce back from an industrial structure like a crane on a jetty. You can reconstruct that structure then. You can tell how high it is, in what position it was, and then put this into context with other measurements you take. You can also do a trick with the laser, and this is basically remove the vegetation from the image. When your laser comes back, it bounces back from the ground and from all intermediate levels. So that way you can remove trees and other structures, and you can then, for instance, reconstruct where a flood will go from a river. When we use our microwave sensor, and that sensor measures the reflected cosmic radiation from the sea's surface, we have to fly at night. So we have to take off at about 2 o'clock in the morning, then go out over the barrier reef or the ocean we are measuring and land back home at base when the sun comes up. The purpose of these measurements is to trace where the nutrients and the remnants of the fertilizers go that are dumped into the Great Barrier Reef lagoon from the big rivers. That is a big problem because these destroy the reef in the long run. If you want to do this with a ship, you have to spend days and months to find these plumes of fresh water. In one night's flight, you can cover hundreds of square kilometers of the reef, and you can see the plumes of the fresh water on the images that you gain from the aircraft. Yeah, sometimes you can see the effect that trees make to the atmosphere. A great example is the rabbit fence in Western Australia, where on the west of the rabbit fence, large tracts of land were cleared of native vegetation and converted into agricultural land, and on the eastern side of the fence there is all natural vegetation. Quite often cloud forms over the native vegetation, which eventually leads to more rainfall over the native vegetation. The reasons for this are many, and that forms one of our prime research topics at the moment. Most researchers in the world today rely to a very large degree on computer models. That is all fine, and it's a very powerful tool. But sooner or later, somebody has to go out in the atmosphere and measure what the atmosphere actually does. Does that reflect what the computer models say? Or are the computer models out? And the only way you can learn that is if you go out there and take measurements. It is very important that this line of research doesn't get lost.